geometry, and we get to learn about like the coolest tool there is, the compass. Bra-bram. So what we're going to be learning about here is basic constructions. And constructions are pretty much, well, here it says here in the book, a geometric figure drawn using a straight edge and a compass. Well, by definition, a construction uses a compass. Okay, and that's going to be helpful for any of you smart Alecs out there that say, well, just measure it with the ruler and a protractor and all that stuff. Well, by definition, a construction uses the straight edge and a compass. So I give you a few things, and I'm going to help you decipher the mystery of the textbook as it tells you how to do certain constructions. So the first thing the textbook shows you is constructing congruent segments. And so remember, what we have to use is a straight edge and a compass. And what I'm going to do is just use similar stuff, right? So the textbook gives you step 1, draw a ray with an endpoint, and then step 2, open the compass, and then step 3 with the same compass setting, put the point, blah, blah. So I'm going to basically give you the same set of instructions, but hopefully in a way you can understand them. But you can always use the textbook, these steps right here. Step 1, draw a ray. You know what a ray is. You know, step 2, open a compass. And step 3, we're going to scribe some arcs. And so I'm going to talk about that in a second. All right, so here's an example. We're going to construct, make sure you can read the directions first. That's normally helpful. Construct segment AB that is congruent to segment EF. Okay, so what I do in this particular example is give you a segment EF, and what we're going to do is construct a whole new segment that is congruent to that. And we'll use a compass and a straight edge. This here is the safety compass, and I like it because it includes a protractor, and it has a ruler on the edges of the straight edge as well. And so a compass has two major components. It has the point of the compass, which is inside the middle of the circle there, so you can see what you're pointing at when it comes to a vertex. And it has a couple of holes that you can look through to scribe your arcs, to make a radius. And the holes are adjustable, okay, with that little thing in the middle. You can adjust the radius of your circle by moving that. Okay, so that's the basic of the safety compass, which is why I enjoy it. And so what we're going to do is construct a congruent segment. So how does it start? Remember what the book said? The book said, draw a ray with an endpoint. And that's what we're going to do. So we just take a straight edge and just draw a ray, right? Simple as can be. We just drew a ray. And it has an endpoint. And so we're going to focus on that endpoint. And then what we do is use the compass and the radius to measure the segment that was given. And so how do we measure that? Well, we're going to line up the point of the compass onto one of the endpoints of the line segment. And so you have to know where the point of the compass is. It's hard to see because it's clear, but on this particular, the safety compass, there's a little nub, like a little knob on there, and you can kind of feel it. But you want to line it up so that the point of the compass is on one endpoint, and you hold it down with one finger, and then you can adjust your radius to find the other endpoint in the hole of the compass. And so now you can see that the other endpoint of the given segment is in the hole of the radius. And now what we are able to do is stick your pencil in there, and you can make an arc. It's called scribing an arc, and that's what you've done. Okay, so that was the second step in the book, and you can see there's the arc you scribe right there. And the book then says, well, keep that length, right? Keep the length and move it to the other endpoints. You remember how we drew that ray? So we're going to line up our compass point onto the endpoint we had and make sure that the compass point is there. And we haven't moved the measurement. Don't touch the compass, right? So don't move that radius. And then put your pencil in and scribe your arc through the ray that you drew. Okay? So once you scribe your arc, you can see what's happening here. So what does this mean? What this means is that the two radii are equal, right? Or congruent. And so what this means is we had the endpoint that we made, and now hopefully you see another point. Do you see another point? And you should see a point right there. There's your other endpoint. So we have now constructed a congruent segment. Okay? But we're not done, because I want you to pay attention to stuff, because I'm kind of a jerk. I want you to pay attention to stuff. I told you to construct segment AB. Didn't I? Yes, I did. Yes, Mr. Katz. So I told you to construct segment AB. You have no labels yet, so make sure that we address the instructions. Okay, now we have constructed segment AB, which is congruent to EF. And that is how you construct a congruent segment. But remember, in the textbook, the steps are the same. This is what we did. We drew an array with an endpoint C. We opened the compass to the length of AB, put the endpoint down, look for the hole. Excuse me. And then make an arc, scribe your arc on the array you drew. Now you have a congruent segment. And then we can play games with you, right? I can tell you to construct segments that are twice the length, right? So maybe you can do it twice. Yeah, fun stuff. But you got to pay attention to that. All right, so that's how we construct congruent segments. All right, so pay attention. Now what we are moving on to is constructing congruent angles. And this is a few more steps, as you can see. This has 5 steps for this process. Right, so we have a given angle, and again, we start with drawing an array. We have scribe a pretty big arc, scribe the same arc, make a couple other arcs, and then you'll find another point. Remember how we saw that last point? So I'll walk you through with an example. So this example is a neat one. We're going to do the exact same thing that the textbook says, but I'll walk you through it. And so my instructions are to draw angle ABC measuring 73 degrees. Whoa, whoa. I thought we were using construction with a compass. Yeah, but I also want to show you how to use a protractor. Why not? So how can we draw an angle ABC measuring 73 degrees? Well, the way we do that is we just begin with array. We can begin with array. And so we make array here. And it doesn't matter how straight the base is. It really doesn't matter. Because what we're going to do is use the protractor of our safety compass to make a 73-degree angle. How does that work? Well, in the safety compass or any protractor you're using, you line up the vertex of your angle into the center of the protractor. Okay, so just like previously, we have the center of the protractor, and we're lining it up on the vertex. Hang on. If I taught that student, that'd be awkward, right? But I don't, so it's all good. Okay, so we have the vertex of our angle in the center point of our compass, and we make sure that the base we drew is flush with the base of the protractor. Hear that word flush, that's what that means. Not flush, and flush. Okay, so we want to use, make sure the protractor is flush. And so we're going to measure 73 degrees. So check out this protractor's degree measurements. Okay, so it starts at nothing, then it gives you a random 15, then a 30, then a 45. So these little notches are going by 5 degrees. Okay, so that's going to be kind of challenging to measure something with 73 degrees because we have a 75 and a 70. So 73 is somewhere between 70 and 75. Okay, so let's say we make a little mark there. If we make our mark there, we now can tell, well, this angle is going to measure 73 degrees-ish or close enough. So you construct your other ray, right? So the vertex of the angle through the point we just made with using your straight edge, right? Definition of a construction using a straight edge. Okay, there, we've made our angle. Okay, so that's how you construct an angle 73 degrees. We did it, done and done. Okay? But pay attention, I am a jerk. I said to draw angle ABC. So make sure we're labeling this angle. Okay, so we label A, B, C with 3 points. Okay, because I am a jerk and I want you to remember that's how angles are named. Now what we're going to do is construct a congruent angle. So we're going to construct a brand new angle, angle DEF. That's what this all means. We're going to construct a brand new angle, angle DEF, congruent to angle ABC. So how does that work? So step one, what we do, step one, same as before, is we just draw a random ray. So you make a random ray. You ever meet a guy, his name is Ray, and he's random? Random ray. So I made a random ray. Now notice what I did. I intentionally made the base of this angle a little bit cockeyed from this one. This just shows you that it doesn't matter. So the first thing we do to construct our congruent angle, a random ray. Now, this is where stuff gets tricky. On the original angle, ABC, we line up the center of the compass at the vertex of our original angle. And then we then adjust the radius to make it somewhat close to the vertex, like give it, a little space. And then what we can do is scribe an arc through both sides of the angle. Okay, scribe an arc through both sides of an angle. Keeping the same measurement on that compass, we're going to do the same thing with the angle we are constructing. At the vertex of our new angle, we place the center of the compass. Keeping the measurement of the radius, we put our pencil down and we scribe an arc. Okay? We don't see any new points except for this, right? Well, here's a new point. That's helpful. But we're going to need a third point, right? So how is it that we can find that third point? We're going to use it the very same way that we found our congruent point with the segment. If you look at the original angle, we now have 2 points. A point here and a point here. What we can do is use the compass to measure that. And so what we can do is place the center of the compass on one of those points. And then we can adjust the radius to find the other points. Okay, so right about there seems to be accurate. Okay, so we have now adjusted our radius to find the other point. So don't touch the compass now. We're going to use that very same measurement on the new angle we're constructing. So you remember we found our point here? We're going to put the center of the compass there. Okay, so we put the center of the compass there. And with the compass setting that we have, we now scribe a new arc. Okay? Now look what just happened. Hopefully you see what I see, which is a new point. Ta-da! Brand new point right there. And so what we do is with that new point, we can connect our ray from the vertex through the new point. And so that's where we use our straight edge, because that's what the construction says we do. We use straight edge and a compass. Now look what we've done. We've totally constructed congruent angles. Yeah, they're cockeyed, but they're the same measure. Okay, are we done? No, Mr. Katz, you're mean. You said to construct angle DEF. Yes, I did. So you want to label the points you made. This is point DEF. Okay, so I do want I want to enforce the naming of angles. Okay, so what did we do? We constructed a congruent angle. So what did we do? We drew a ray. We made the big circle on the original angle. We then scribed that same circle on the new ray. Then we measured our distance from point to point on the original angle and scribed the new arc. And then we drew our connecting line. Okay? And again, as you can see in the textbook, sometimes I'll ask you to do it twice, where it's twice the measure of stuff, right? So this gets fun. Anywho, we're going to start talking about bisectors next. Okay, bisector. So we have to know what bisector means. Okay, and the first bisector we're going to construct is an angle bisector. I'm going to skip problems. So what does bisector mean? Bisector means cut it in half. Okay, so bisector means we're going to cut it in half. So let's work on a construction that deals with constructing a bisector. Here are the steps in the textbook. I'll show you what they might look like. Okay, I'm going to give you another problem. So this one's a neat problem because I'm kind of neat. I'm telling you to construct angle B on paper. That's up to you. You make an angle. So we're going to do that. Okay, so what I'm going to do is make a random angle. And to make a random angle, I'm going to start with our friend random ray. So make a random ray. That's random. I'm going to make a random angle. Okay, so from ray, ta-da, there. I have now constructed angle B. Okay, so totally randomly, angle B. Now what I'm going to do is construct angle A that is congruent to angle B. So the steps we just took on number 2, I'm going to do the same thing here, but make an angle congruent to this. So I'm going to construct angle A that is congruent to angle B. I'm going to go down here. Okay, so how do we make a construction of congruent angles? Start with our good friend, random ray. So have a base, a random base, and there's my vertex of the new angle eventually. From the original angle, I line up my compass center. I adjust my radius to however I want. I scribe an arc to cross both sides of the angle. Keeping that compass measure, I go to the vertex of my random ray. and I scribe the same arc. In my original angle, I now see 2 new points. So I'm going to measure those 2 new points using my compass. I line up the center of the compass on one of the points, and I adjust my radius to find the other point. Okay, it's probably as low as I can go, so I got lucky there, right? So there, that's about lined up. And so using that same compass measure, I go to the new point we have on our new ray. I put the center down there. Make sure the center is lined up. Sometimes it's hard to see. And then through the hole of the compass, scribe an arc. And ta-da, a brand new point. Wow. And now I can connect my vertex of the random ray. I have now constructed a congruent angle. Okay, so notice these angles are pretty darn close, right? So I've constructed angle A. Mr. Katz, angle A, right? Remember who you're dealing with, folks. I'm crazy. So I put the angle A there. Now I've labeled it. Now, I'm going to construct the bisector of angle A. So I'm going to cut this angle in half. I'm going to cut this angle in half. Now, how does that work? Well, the first thing I want to do is kind of erase the mess I made so I don't get too confused. Okay, so don't erase your angle, but erase the mess you made so you don't get too confused. The arcs are going to be all over the place. So I'm going to construct the bisector to the angle I just drew. So the first thing I'm going to do is line up my compass with the endpoint on the vertex, or the center of the compass on the vertex. I'm going to adjust my radius to whatever. However, the whatever I adjust it to, I ain't going to touch it. So once I adjust it to there, I'm done. Don't touch it. All the radii we're going to use, all the radii we're going to use, are going to be the same measure. So I'm not touching the compass length anymore. That's why the safety compass has like those rigid things. In case it's, they're pretty tight there. So with the one setting, I'm going to scribe an arc through one side of the angle and scribe an arc through the other side of the angle. And you can have a continuous semicircle, that's fine. Okay, so what just happened? We created 2 new points. Bam, bam. Remember, don't touch the measurement of the compass. Keep it there. And if you do adjust it, start over again with the same measuring. Okay, notice how we have these 2 new points. I'm going to line up the center of the compass on one of the new points and then scribe an arc way out here. Okay? And don't touch the compass. On the other new point, put the center of the compass on the other new point and scribe an arc way out here. And notice what just happened. You have now invented a whole new point. Wha-bam! How much fun is this stuff? It's awesome. So now we have a whole new point. Now remember, what is the bisector of that angle? It cuts the angle in half. So we now have that new point to the vertex. We can now cut that angle right in half, samurai style. What y'all? So samurai style, we've cut that angle in half. We've now constructed the angle bisector. But, Mr. Katz, be careful, because I told you to label the bisector ray AC. Okay, so here's A. Make sure you label that point C, because I need you to know that the bisector is ray AC. Okay? Okay. So that's constructing the angle bisector. The steps are right here. They're in the book. Right? Put the compass on the point, the vertex, draw an arc that intersects both sides. Right? And then have your fixed distance, and then you scribe a couple arcs there to make your other point. Okay, so it's what we just did. The things are right there. Okay? Now look at this question. It says draw an obtuse angle. Happens.
At this time, if you are no longer with a supervised faculty
Check this out.
in an extracurricular activity, then you need to exit through the iron gates.
Come on, Mr. B, make it quick.
Hope everybody had a wonderful Tuesday. Again, if you are not with a supervised faculty member in an extracurricular activity, you need to now exit through the iron gates and wait for your ride there.
Dead time.
Have a great rest of the Tuesday, and we'll see you bright and early on Wednesday. Go Cougars. We love you.
Dead time. I'm going to let him know what he did. He'll feel bad. All right, so so that's it for constructing the angle bisector. It's right there. Last construction of this video, and thanks to Mr. Barnard for making it video longer. But the last construction. We're going to sketch a segment on the paper. It says sketch segment LM on paper. Fine. So what I'm asking you to do, you can totally make a random segment. Here, random segment. but we're going to call that segment LM. Ta-da! I didn't measure it because it doesn't matter, but now that is segment LM. And now what we're going to do is construct segment AB that is congruent to LM, just like we did in problem 1. So how do we construct congruent segments? Remember our friend random ray. Okay, so we're going to make a random ray, and here's my endpoint. I'm going to use the compass to measure the original segment. I line up the center, and I use the radius to find the other endpoint. I think that's it. Yeah, that's it. It's hard to see with the graphite, you know, whatever. All right, that looks good. So I have the compass measure. I keep that compass measure, and I line it up with the new endpoint of our random ray. And then I scribe an arc. And now we no longer have random ray. We have a congruent segment. Okay, so we've made our congruent segment, but I said segment AB. So let's label that segment AB. So now we've done that. Here's the last construction of the day. Construct the perpendicular bisector of AB. What is this vocabulary, cats? So what is the perpendicular bisector? It's right here. The perpendicular bisector cuts a segment in half using a 90-degree angle. Whapash! We have to remember what perpendicular lines look like. They create 90-degree angles. So the perpendicular bisector slices a line segment in half, making two congruent segment pieces and creating the midpoint. So the perpendicular bisector of a segment is quite fun because it just does so much. So that's what I'm asking to do here, and I'm saving this one for last. So here are the steps of constructing a perpendicular bisector in the textbook. Put the compass on blah, blah, blah. I'll show you, but it's, all the steps are here. But this is what we're going to end up drawing. It's kind of fun. We're going to be using semicircles. We'll use longer arcs, basically. Okay, so we're going to construct the perpendicular bisector of segment AB. So how does that work? You line up your compass center on either of the endpoints and adjust your radius to wherever. Like you eyeball halfway. So you adjust your radius to wherever, you eyeball halfway, like, you know, halfway here. And then what you can do is make a pretty wide arc. Okay, so make yourself a pretty wide arc on that endpoint. Without touching the measure of the compass, you move the center to the other endpoint. Okay, the center to the other endpoint. And again, this is hard if you're right-handed. Again, you line up, don't touch that compass, and make a pretty wide arc. Once you have made that second wide arc, look what has happened with your arcs. You have created two new points. Ba-bam here and ba-bam there. And guess what? Postulate 1-1, any 2 points creates a line. So we have now created the perpendicular bisector of that segment. How cool is that? Right? So we've now created the perpendicular bisector of that segment. Now some neat vocab from this little picture. Guess what the perpendicular bisector does? It cuts the segment in half. So if it cuts this segment in half, right, if this from here is equal to this there, you know, if this is 2 tick marks, then this is 2 tick marks, right? They're totally congruent distances. That means this is the midpoint. Okay, so that's the other part of the question. Label the midpoint C. Voila. And we are done with our basic constructions. And if you forget anything, you can use the steps in the textbook, or you can watch this video again, but have some fun with the compass. It's such a neat tool. Okay, so enjoy, good luck, finish your assignments, and I'll see you on the flip side.